All right, getting into our Chapter 19 notes. I know this says Chapter 18. When you print these out, your notes will say Chapter 19, though. This is our old book had the same chapter, but it was 18, and now it's been updated to 19. So Chapter 19, Lesson 1. We're combining the first two sections together because 19.1 is extremely short. It's just one concept, and that's what you're seeing right here. This is all you need to know from Section 1 of Chapter 19. And that's just the difference between continuous data and discrete data. But this is important because these are questions that you'll be asked on a test. So quite simply, the difference is discrete data is any data that can be counted. And so if I was going to do, say, a survey on the number of students in this class, let's just say I wanted to know how many students were going to go to the next football game or how many students were going to the next dance or whatever. But if I was dealing with a number of people, that's something that can be counted. I can always count the number of people doing something. It's generally whole numbers. I can't get like half of a person, so people is something that could be counted. If it was going to be maybe the number of desks or the number of objects, something that can be counted, those things are discrete. Continuous data is data that can be measured, and that's your keyword right there, is measured. So if you're following along with these notes, you want to highlight the word counted for discrete and the word measured for continuous. So anything that can be measured, such as if I was going to find out the average height of the students in our class, or length or width, or anything that could be measured would fall under the continuous data category. So do know the difference between those two. You'll get a couple practice problems for these in tonight's homework. But you do need to know the difference. You'll get a couple questions on the test where you're just given scenarios like this, and they will ask you whether it's discrete or continuous. So we've got to make sure that you know the difference between those two things. The rest of this lesson is going to focus on 19.2, which is grouping data within a frequency table. So there is a process for doing this, and so follow closely here. This is how we'll group data. If you took a look at this big list of data, and obviously this could be a lot longer, but if I had a big long string of numbers, that might be really hard to work with, that kind of data, and so it might make more sense to group it within a table like this, within a frequency table. It just helps categorize things, kind of shrink down the data so it's easier to look at by putting them into groups. And so here's the couple steps that we're going to go through on how you could do this. So if we're going to say start by just choosing the number of classes that we want, that's something that would be given to you. So this isn't something you have to decide. You'll be told how many classes to come up with. So we're going to be working with this list of data right here. And let's just say we were told to create a frequency table with 8 classes in it. And so for this particular problem, we're told that we're going to be using 8 classes. So how do we determine the class width? Well, if we take the highest value minus the lowest value and divide it by 8, because we're using 8 classes, that's going to tell us how big to make our class width. And so if you look at this one, the biggest number within this set of data is 35, and the smallest value is 5. And so if I subtract those, 35 minus 5, which, by the way, we do have a special name for that. That's the range of the data. So 35 minus 5 is 30. So 30 would be the range. So I'm taking the range of 30 and dividing it by the number of classes that I want. So 30 divided by 8 is 3.75. And in this case, I must always round up. And so I need a class width of 4 units. So even if that said 3.1, I would still have to round up to 4 to get my class width. Simply being because if I don't round up, then my largest number that I have won't fit within my last class of data. And so that's why I always have to round up. Otherwise, I'm going to lose out on that last data value. So we always round up. So if I want my class width to be 4, and here's where you look at for step 3. So my lowest value is the lower limit of my first class. And here's what that means. Since the smallest value is 5, then my first class is going to start with 5. And since I need a width of 4 units, I'm going to go all the way up to 8. So think about that for a minute. That would include 5, 6, 7, and 8. So I have 4 units of data within this class, and so that's why we're going to go from 5 to 8. Oftentimes students will look at this and they really want to go from 5 to 9 because they say, oh, well, 9 minus 5 is 4, so there's my class width. Doesn't quite work that way. You got to pay attention to this number to this number and what all is included. So we're including 5, 6, 7, and 8, so that's 4 data values. So that's why we have a class width of 4. So if this class ends at 8, well, then my next class would begin at 9. And again, since I want my class width to be 4, then I would have 9, 10, 11, and 12 within this class. And then again, for the next one, I'm just going to pick up where I left off. So I would start with 13, and I have 13, 14, 15, and 16 would be the next 4 pieces of data would go within that class. And we continue all the way on until we have a total of 8 classes. You'll notice that within our last class, if this goes all the way up to 36, we're safe because my biggest value is 35, so I know all of my data is going to fit within the classes that I have. And that's why we rounded up. And so these are going to be the 8 classes. And there's going to be some questions that you'll run into where that's all they ask of you is they just want to know what are the 8 classes. And so this would be our list of classes that we would have. From here, we're going to figure out how many pieces of data fit within each class. And so if I look for the values that are between 5 and 8, including 5 and including 8, so any value of 5, 6, 7, or 8, and if I count how many of those I have, I'm going to put that amount of data within that frequency for that class. So there were 8 values, somewhere between 5 and 8. And then if we just keep going on down the line, so how many data values are between 9 and 12? And so if we found those, there was only one value that we could find for that class. There were none from 13 to 16. And just kind of keep on going down the list here. There were 6 data values from 17 to 20. There were none from 21 to 24. None here. There's only 1 piece of data from 29 to 32. And 2 pieces of data from 33 to 36. If you add all these up, you should find that you have everything accounted for, and that's important. So if you were to look at these data values right here, so we had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 pieces of data, which means if I add up those numbers, they should add up to 18, and that's how I know that I have everything accounted for. So that's how we create a frequency table, a grouped frequency table, because we group them by classes, and we listed out our frequencies over here on the right. So this is how we create our frequency table. There's different ways that this information can be presented to you. We're going to be looking at all those different ways of working with these statistics throughout the chapter. Just as a side note right here, you'll notice that within these classes, there is a gap from class to class. This class ends at 8, and this class begins at 9. So what if I had a data value that was 8.5? Where would it go? Right? There wouldn't be a place for it to go, but because this list was only working with whole numbers, that wasn't an issue for these, and so that's why we could have that gap. But to take care of that gap, this is the way oftentimes your book will present the information so that you don't have any gaps, and so that if you do have decimals, you'll know where to put them. So take a look at the way this is written. Let me explain this really quick because this will come up within your book. If the book tells you to create classes that look like this, and then you would just continue on. So oftentimes the steps that we took right here to figure out our classes, sometimes the book just skips some steps and they just say, here you go, use these classes. And so we don't have to necessarily go through all those intro steps. We can just use what the book presents to us and then continue on where they left off. So if you look at this, here's what this is telling you. This is saying that the first class would go from 5 to 9. The next class goes from 9 to 13, 13 to 17. And what you'll notice is the hard bracket that you see right here means you do include this number. The parenthesis means you do not include this number, which means This goes from 5 to 9, but does not include 9. This goes from 9 to 13, so this one does include 9, but would not include 13. Simply put, the reason they're doing that is, well, if I have a value of 9, where do I put it? Well, this one does not include 9, but this one does. And so if I have a value of 9, it would go within this class right here. If I had a number like 13, it would go here because this one does not include 13, but this one does. And the reason they write it like this is if I have decimals, well, there's no spaces from this class to this class. Where this one ends, this one begins. There's no gaps, and so you'll have a class for every piece of data, even if decimals are involved this way. And so this is just some notation that you got to be familiar with in case it's presented to you this way. So this is how we make a frequency table. For frequency tables, there is a special kind of a graph that goes with frequency tables, and you've probably seen this before, but this is called a histogram, otherwise known sometimes as like a bar chart or a bar graph, but this is the official name for it, is a histogram. Be familiar with this. You're going to see a question on the test that asks you to make a histogram. There's other graphs like a box and whisker plot, and oftentimes the test might ask you for something like a histogram, but a student might make a box and whisker plot instead because they forgot their terminology. So just make sure that you understand what a histogram is and how we distinguish that between other graphs that we'll run into within our statistics chapter. So anyway, here's how we make a histogram. We're going to pull the data right off the table that we see up above in order to create our histogram. So right here on the left side, the y-axis are the frequency values. So that's these guys. These are the y data points, and these are the x data points. And so this is like an x-y chart that you see right here. So we have the frequencies on the left, and we have the classes, the x values that are going to go right down here. So here's a really important concept that IB requires when you do a histogram. When you make a histogram, you are not allowed to have any spaces or any gaps from one bar to the next. Well, if you look at our values that we have, there's naturally a gap because we have a space between 8 and 9. So to close that gap, what they would have you do is to put a point in between them. So instead of classes down here on the x going from 5 to 8 and then 9 to 13, right? Well, that would leave a gap. So instead of doing that, we're going to use the numbers in between these to help make our chart, our graph. So we're going to go in our first bar, we're going to go from 4.5 to 8.5. And then we're going to go from 8.5 to 12.5, 12.5 to 16.5, so on and so on. That's important because that way our bars will all be connected and we won't have any spaces in between. You need to pay attention to that because if you didn't follow those rules on a test, you would be marked down, and that will come up on a test, so pay attention to that. Here's one benefit to having classes like this is naturally they don't have any spaces, and so if it was written this way, I don't have to worry about using 0.5s because there are no gaps. This one ends at 9 and this one begins at 9, so there are no gaps when it's written this way. And so if you have to make a histogram from this type of a class setting, then you don't have to worry about any decimal points. Just go from 5 to 9, and this would go from 9 to 13. There won't be any spaces, so you can just use the actual numbers that you see here. But this one did have gaps, so we are using decimals in between, like 8.5. Within each class, we just need to identify how many frequencies are in that class. And so within our first bar, if we go from 4.5 to 8.5, like you're seeing here, well, we had 8 data points within that class, and so this bar will go as high as 8. And then if we go to the next class, this next one is going to go from 8.5 to 12.5, and it has a total of 1. And so here we are for the next one. We went from 8.5 to 12.5 as high as 1. If it doesn't have any data within a specific class, still put something there. Put a 0 just to help you connect where the next bar would start, and that way you don't miss anything. You got all your numbers accounted for. It will just help you keep everything organized. And so you can see within the next class from 12.5 to 16.5, that went up to 0. From 16.5 to 20.5, we go all the way up to 6. And then if you just continue on all the way through the rest of those numbers, we're going to come out with a graph that looks like this. And this is what would earn you all the credit for your histogram. So again, notice I didn't have any gaps in between my bars. I have all the numbers accounted for. Again, if I add up the frequencies that I have here, right, they added up to 18, which means I accounted for all of my 18 pieces of data within that graph. When doing these, really important, this is an IB requirement, is you must label your axes. So especially those of you taking the IB test, you need to label what your y-axis represents and what your x-axis represents. So really important that you label those. And again, it might have something more specific here, like this might be the number of students, and this would be whatever class that represents. And so if you are given other specific information for those, then we would just use those to label the x-axis and the y-axis with whatever that information was. Your calculator can do histograms. I did post a YouTube video on my website for how to do that, but I stopped showing it in class because it is way more trouble than it's worth. These are not hard to do by hand, but it is pretty challenging to get all this correct on your calculator. So I would highly advise you to not try to learn it. It's just one of those things that you just really don't need it. Histograms are easy to make. There's really no benefit to learning how to do this on your calculator, so you don't really need to spend the time doing that. So doing these by hand is pretty simple to do, and so we'll stick with that. We don't really need to deal with the calculator portion of coming up with this graph here.